Tesla has just made the Semi lighter, faster charging, and significantly more profitable. The redesigned truck, internally codenamed Atlas, has now been spotted testing on public roads. But what's even more interesting is that initial feedback from fleet operators has begun to emerge. Bali Express Services just wrapped up a 3-week trial with a Tesla Semi. In a post on X, the company stated that the experience proved the next generation of transportation will be shaped by technology, sustainability, and operational efficiency, not tradition. Bali Express even emphasized that electrification is not just a trend but a strategic commitment to reducing emissions, improving fleet performance, and building a more sustainable supply chain. And here's the most notable detail. Bali Express is reportedly preparing to add 20 electric trucks to its fleet in 2026, including the Tesla Semi. If this plan moves forward, it will be a much stronger signal than a simple customer compliment coming from a haulage company that has tested, evaluated, and subsequently chosen to expand its electrification efforts firsthand. So what has Tesla actually changed? And why might these upgrades matter to logistics companies even more than the Semi's new design? The first major upgrade that deserves attention is weight. Tesla has reportedly reduced the redesigned Semi's weight by roughly 1,000 pounds compared with the original production version. For a passenger vehicle, removing 1,000 pounds can improve acceleration, handling, and efficiency. For a Class 8 truck, however, the economic impact can be even more important because weight directly affects how much cargo the truck can legally carry. Every pound removed from the tractor potentially creates additional room for payload while remaining within federal gross weight limits. That means Tesla is not simply making the Semi more efficient, it is potentially making every trip more productive. The numbers make this particularly interesting. The long-range version is listed at approximately 23,000 pounds unloaded, while its maximum gross vehicle weight is 82,000 pounds. The standard range version weighs less than 20,000 pounds. In commercial trucking, these numbers matter because fleet operators do not make decisions based solely on range or horsepower. They care about how much freight can be moved per trip and how much revenue can be generated from each truck. A lighter tractor can therefore create value without increasing battery capacity or adding more power. Tesla may effectively be turning weight reduction into additional earning capacity. The second major upgrade is the powertrain. The redesigned Semi uses a 3-motor configuration mounted at the rear axle with output of up to 800 kilowatts, equivalent to more than 1,000 horsepower. But the important question is not whether a truck has enough horsepower to produce impressive acceleration. The real test is whether it can maintain efficiency and performance while hauling heavy loads for hours at highway speeds. A commercial truck spends its life working, not performing short acceleration runs. The 3-motor system gives Tesla the ability to balance power delivery, efficiency, and traction while carrying substantial weight. That becomes particularly relevant on routes connecting distribution centers, ports, warehouses, and border crossings. A truck operating between Southern California and Mexico can encounter long highway stretches, elevation changes, traffic, and repeated stops. For a fleet operator, a powertrain that can maintain predictable performance under those conditions matters far more than a headline acceleration figure. Tesla's redesign therefore appears to be focused on making the Semi a more capable industrial machine rather than simply a larger version of a passenger EV. The third upgrade may be the one that has the greatest impact on how electric trucks are actually deployed: charging. Both versions of the redesigned Semi support MCS 3.2 charging, with peak charging power of up to 1.2 megawatts. Tesla says the system can restore roughly 60% of the truck's range in about 30 minutes. That changes the conversation around electric trucking because charging time is not necessarily the same thing as lost operating time. For a fleet operator, a truck already has periods when it cannot legally or operationally remain on the road indefinitely. Drivers need breaks, loading takes time, unloading takes time, and vehicles often spend time at depots or distribution facilities. If a large portion of the battery can be replenished during one of those unavoidable stops, charging becomes integrated into the operating schedule rather than becoming a completely separate source of downtime. That is one of the most important advantages Tesla needs to prove in real-world fleet operations. And this is where Bali Express becomes particularly relevant. The company's 3-week Tesla Semi trial provides a real-world environment in which Tesla's claimed advantages can be evaluated against actual freight operations. The company operates cross-border logistics from Southern California toward Mexico, making route predictability, charging infrastructure, payload, and uptime critical factors. According to reports, Bali Express also plans to add approximately 20 electric trucks to its fleet in 2026, including Tesla semis. That potential expansion is significant because it suggests the trial was not viewed simply as an experiment with new technology. There is another piece of context that makes this deployment even more interesting. Bali Express has been recognized for its role in establishing a green truck corridor connecting Long Beach with Mexico. Such a corridor provides an unusually suitable environment for electrification because commercial vehicles can operate along established routes where charging infrastructure can be strategically placed. Instead of asking an electric truck to handle unpredictable long-distance routes across an entire country, operators can initially deploy it where the route, depot locations, cargo patterns, and charging requirements are easier to manage. This could explain why regional and short-haul freight may become one of the first areas where the economics of electric trucking become difficult for diesel competitors to ignore. A truck that returns to the same depot every day has a completely different charging problem from a truck that travels thousands of miles through unfamiliar territory. Tesla can use predictable routes to maximize charging efficiency, reduce downtime, and keep vehicles highly utilized. The Semi's 1.2 megawatt charging capability becomes much more valuable when the charging schedule can be planned around the truck's existing operating cycle. The redesigned exterior also deserves attention, but it should not be the centerpiece of the story. Atlas features a horizontal light bar integrated into the front end, following a design language Tesla has increasingly used across vehicles such as the refreshed Model Y and Cybercab. The bodywork has also been refined to improve aerodynamics. These changes may look cosmetic at first, but aerodynamics become extremely important for a truck that spends most of its working life at highway speeds. Reducing aerodynamic drag can lower energy consumption, which translates directly into lower operating costs and potentially greater range from the same battery. Taken together, the upgrades reveal a much bigger strategy. Tesla is not simply trying to build an electric truck with a larger battery. The company appears to be attacking the economics of freight transportation from multiple directions. Reduce the tractor's weight to increase payload, improve aerodynamics to reduce energy consumption, use a powerful 3-motor drivetrain to maintain performance under heavy loads, and deploy 1.2 megawatts charging to minimize downtime. That is why the public road testing of Atlas matters. Tesla is now moving from the stage of showing an updated Semi to proving whether those improvements work when the truck is actually moving freight. Bali Express provides another important piece of that puzzle. If its planned fleet expansion proceeds after the 3-week trial, it could become an early example of how Tesla's redesigned Semi transitions from an engineering project into a genuine commercial asset. The real breakthrough, therefore, may not be the Semi's new appearance at all. It may be the fact that Tesla is trying to make an electric Class 8 truck economically competitive at the level that matters most to fleet operators. More cargo per trip, less energy per mile, less time spent charging, and more productive hours on the road. If Atlas can deliver those improvements consistently in real-world operations, the redesigned Tesla Semi could represent something much bigger than a new generation of electric trucks. It could be the point where electric trucking starts competing with diesel not only on environmental benefits but on the fundamental economics of moving freight. So, how is Tesla scaling Semi production in Nevada? Tesla's aggressive hiring in Nevada suggests that the Semi program is moving into a much more serious stage of industrialization. The company's careers page currently lists hundreds of full-time positions across manufacturing, engineering, logistics, quality, and other functions at Gigafactory Nevada. Of the roughly 471 full-time positions, around 146 are specifically tied to the Semi program. That means nearly 1/3 of the listed openings are directly connected to the electric truck, an unusually strong signal of where Tesla is concentrating its manufacturing resources. The timing is important because Tesla is no longer treating the Semi as a limited pilot program. The company has been preparing dedicated manufacturing capacity in Nevada with a long-term target of producing up to 50,000 Semi trucks annually. That figure is dramatically higher than the small number of pilot vehicles previously produced and indicates the scale Tesla ultimately wants to achieve. Reaching that level, however, requires far more than simply assembling more trucks. Tesla needs production workers, manufacturing engineers, quality specialists, supply chain personnel, maintenance teams, and logistics operators working together to create a repeatable, high-volume manufacturing system. This is why the 146 Semi-related positions may be more significant than the headline number of trucks currently leaving the factory. Tesla is building the organization around the product before reaching maximum production. In other words, the company is adding the human infrastructure needed to support a production ramp rather than waiting until the factory is already operating at full speed. The current semi-production program is also transitioning from validation to commercial deployment. Tesla has already placed pilot and early production semis with major customers such as PepsiCo and Frito-Lay, giving the company an opportunity to collect real-world data on energy consumption, reliability, charging, maintenance, and route performance. Those vehicles are particularly important because Tesla can use their operating data to identify problems before scaling production to thousands of trucks. The redesigned Semi adds another layer to this ramp. The updated truck features major changes to its powertrain, weight, aerodynamics, and charging system, meaning Tesla has to validate not only the vehicle itself, but also the manufacturing processes required to build it consistently. A production ramp therefore becomes an engineering challenge as much as a staffing challenge. The factory's location also gives Tesla an important advantage. Gigafactory Nevada already has experience producing large-scale battery and energy products, while the Semi program can leverage Tesla's existing manufacturing ecosystem, supplier relationships, and battery expertise. As production increases, Tesla can potentially improve economies of scale across components that are already being produced for other parts of its business. But the real question is how quickly Tesla can move from early production to meaningful volume. A target of 50,000 trucks per year would require an average of roughly 137 semis every day if production ran continuously throughout the year. That is a completely different manufacturing challenge from producing hundreds or even a few thousand pilot vehicles. This is why the hiring numbers matter. If Tesla were still treating the Semi as a small experimental project, there would be little reason to build such a large workforce around manufacturing, quality, engineering, and logistics. The concentration of semi-specific openings suggests Tesla is preparing the operational foundation for a much larger production ramp. And that could become one of the most important developments for the Semi program. The biggest story may no longer be whether Tesla can build the Semi. It may be whether Tesla can build tens of thousands of them efficiently enough to compete with diesel trucks on cost. If Tesla succeeds, the impact would extend far beyond the launch of another electric vehicle. A 50,000 unit annual production capability would give Tesla the scale to target major fleet operators, regional freight corridors, and eventually a much larger share of the Class 8 trucking market. For now, the hiring surge in Nevada is one of the clearest signals that Tesla is preparing for that next step. The Semi is moving from a technology demonstration toward an industrial-scale manufacturing program, and the workforce being assembled in Nevada could determine how quickly that transition happens.